Hi, hello. In this video, we are going to learn about data collection plan, right? That means we are in the measure phase. We wanted to have a proper plan so that we can actually collect the data, which is credible for calculating the baseline, and then we can also continue with the analysis. So we are going to learn about data types. We're also going to learn about another important tool called operational definition and then the data collection plan. So these are the topics. Identifying what to measure. That is the CTQs we wanted to measure. Critical to quality characteristics. And then data collection plan and then data types and operational definition. So what is a CTQ measure? CTQs are the key measurable characteristics of a product, service, or a process whose performance standards or the specification limits must be met in order to satisfy the customer, right? Then generally the CTQ measure will include the tolerable limits. We call them as specification limit. You will have an upper specification limit. You will also have lower specification limit. And in addition to the specification limit, is there any other feature or the characteristics related to the product or service needs to be monitored or measured, and that can also be included, right? This is called CTQ measure because the Six Sigma project is optimizing the Y by optimizing the X. What is that Y variable we are trying to optimize? For example, let's say the strength of a material. The strength of the material is not uniform. It is some of the certain material. The strength is high, and for certain material strength is low. We want a constant strength in all our products. So strength is the CTQ measure here, and strength needs to be at a customer specified level. Let's say the compressive strength should be 100 Newton per mm squared. So 100 Newton per mm squared is the compressive strength expected by the customer. And then customer can also give you a tolerance plus or minus 5. That means 100 Newton per mm squared is the target value. Plus 5 will give you 105, and 105 is the upper specification limit, and 95 is the lower specification limit. In addition to the strength, if you would like to measure some other characteristics, for example, the cross-sectional area or any other feature that you would like to measure and monitor, and then you wanted to understand out of it, then you can include all these things. Then that format is going to be called the check sheet. So data type. Fundamentally, there are two types of data exist: continuous data and then discrete data. So what is data? Data is nothing but any numerical value, or data is said to contain some information, right? It can be a numerical value, or it can be a statement also, descriptive statement also. And so basically there are two types of data exist. One is continuous, another one is discrete, right? And continuous data is quantitative data that can be measured, that can be measured. So any measurable characteristics is a continuous data. For example, I want to measure the strength of the material. I want to measure the length of the product. These are all continuous data because anything that you can measure is a continuous data. And we call it continuous data because it has an infinite number of possible values within any prescribed range, right? For example, when I measure strength of the material from I know the strength of the material can vary from 95 and go up to 105. That's the specification limits. And now any product in which I measure the strength, the strength can be any value between 95 and 105, and that's what is written here. Infinite number of values are possible. Such data are called continuous. And discrete data is quantitative data that can be counted. For example, I want to know how many products rejected in a shift, How do I get this information? I will actually count the number of products rejected. Whenever you collect data by counting, then the collected data is discrete data. And another example written here, the number of students in a classroom. How do you know the number of students? You just count them, isn't it? So countable data are discrete data, measurable data are continuous data. So to get to know little more deeper understanding, so we are now talking about data. We are talking about variables. Basically, there are two variables. One is qualitative variable, another one is quantitative variable, or qualitative data and quantitative data. Suppose, let's say I collect information about the name of the employees who are working in my company. Now I get a list of names, and now the data I collected is qualitative. The qualitative data also carries information, but it is written in a in the form of just textual data, not numerical data. For example, the brand of a personal computer, the marital status of the employee, and all these things are qualitative data. Coming on to the other side, let's say I measure the length of a product and then document it. Now it is a numerical data, so it is quantitative. I collect the information about the age of my employees. Now it is quantitative, isn't it? And within quantitative, you have two types. One is discrete, another one is continuous. So what is continuous here? Any measurable characteristics about a product, service, or a process is called continuous data. For example, I want to measure your height. Height is measurable. I want to know your weight. Weight is also measurable. I want to know the length. It's measurable. Surface finish, it's measurable. Compressive strength, it's measurable. The fill volume, it's measurable. Isn't it? Anything that is measurable is called continuous data, right? And if the characteristics is only countable, then it is called discrete data. For example, the number of units produced in a shift. Now, how do you know how many units are produced in a shift? You just count it, right? There are about 100 units produced, 1000 units produced, and these are all countable data, discrete data. Discrete data will always be in whole number. Continuous data can be in whole number also, can be in decimal also. Some other examples here. Number of children in a family. Number of children in a family, maybe 2, 1, or 3, some whole number always. And the number of strokes on a golf hole, right? And these are all countable. And number of TV sets in a family, and this is also a whole number. These are all discrete. The number of machines you have in your factory, and that is a discrete data, right? So I think you all got a clear idea about the continuous data and discrete data. Both are forms of quantitative data. Continuous data means measurable characteristics. Discrete data means countable characteristics. Please note one important information I am going to share. For all measurable characteristics only, you can calculate average. For all countable characteristics, we are going to calculate a statistics called proportion. So what is this difference between average and proportion? We will be learning in the analyze phase. Right. And now just to test your understanding, and now we are going to together categorize the data written here into either continuous or discrete. The first one, turnaround time. Turnaround time, is it a continuous data or a discrete data? Turnaround time means it is measurable, so I'll put it in continuous data. Customer satisfaction score. Customer satisfaction score on a scale of 0 to 10. Now you can either give 0, or you can give 1, or you can give 2, 3, and so on up to 10. That means only 11 possible values are there. Either you can say 0 or you can give 10. So since the number of possible values are finite and only fixed values are possible, and you can't expect decimals here, and it is discrete data. Number of transactions failed. Number of transactions failed is measurable or countable? It is countable. So that is also discrete. The maturity amount, your maturity amount, maybe, after you have opened an FD account and the maturity amount can be in decimals. So it will fall under continuous data. Total available balance in your savings account. Can it be in decimals? Yes, then it is continuous data. Time you have taken to resolve an issue, time is measurable. Time is measurable. So that is also continuous data. The number of cards that are linked to a savings account. This is countable, isn't it? So that is discrete data. Time taken to process a loan application. Time is again measurable. That is continuous data. Number of clients you have served, in a particular duration. That is discrete. Hope all of you gain the absolute clarity. What is the difference between continuous and discrete data? Continuous data means measurable. Discrete data means countable. Because this understanding is important, for selection of statistical tools. The selection of statistical tools mainly depends on the type of data, right? So you should master this. Now, unit of measurement and operational definition. Any characteristics that you measure, there has to be a unit. For example, you are measuring time. Tell me, how do you want to measure the time? Do you want to measure the time in terms of seconds, in terms of minutes, in terms of hours, or in terms of day, or in terms of week, or in terms of month, or in terms of year, isn't it? What is more, most relevant? That measurement unit you should follow, right? Every characteristics will have an unit, which the appropriate unit must be used. And then in order to measure any characteristics, there has to be a description about the characteristics. Then only people understand correctly, and then they will measure correctly for you, which is called operational definition. So unit of measure is used as a standard for measurement of the same kind of quantity. For example, temperature, sometimes we need to measure in degrees centigrade. The weight we need to measure in terms of kilogram. The volume we need to measure in terms of liter. The time we need to measure in terms of seconds, and so on. So which is most appropriate and more apt for your particular characteristics? You advise all your team member to measure the characteristics using the same unit, right? That's very important. And then operational definition. What is operational definition? It's a short description about what you actually wanted to measure. So an operational definition can be defined as a clear and understandable description about what is to be observed and measured, isn't it? Otherwise, what happens if you say you measure the diameter? People will measure the diameter only. You have to tell how to measure the diameter, how the measuring equipment should be held in your hand, and how you should hold the workpiece, and where exactly the diameter should be measured, and each and every information should be given without creating any ambiguity. So a clear, concise, and unambiguous statement about the characteristics to be measured is called operational definition. If you don't frame the operational definition correctly, and if it creates ambiguity, then what will happen? That becomes the source of error, and then your data can become useless. So we have to be very careful while writing down the operational definition. See here, I have written some operational definition. Maybe they might be related to certain domain. See, order lead time. I think this is related to the restaurant kind of organization. The amount of time it takes from the moment the patron places the order to the moment the order is delivered. So the moment the order is received and the moment item is delivered, the time in between is called lead time. And similarly, the preparation time, the cooking time, the customer waiting time. See, all of them are time only, but there is a lot of difference, isn't it? So we should clearly make our people understand what do we mean by preparation time, what do we mean by cooking time, what do we mean by customer wait time, what do we mean by the lead time. This has to be made very clear, and for that purpose operational definition is required. And now a check sheet we are trying to develop, nothing but a format. Look here, what is the characteristics you want to measure? Right, the Y measure. Y measure is the CTQ. You can write here diameter, you can write here length, you can write here surface finish, You can write here compressive strength. You can write here the number of units rejected, whatever you wanted to write. Right? The characteristics that actually drives your result, that has to be written. And then what is the operational definition for it? A clear and concise, unambiguous statement about the characteristics you want to measure. And then where from that data must be sourced. You want to collect the data from all machineries, from all your lines, or any specific line from where you wanted to measure. So that instruction should come. That means the source of the sample. And then sample size. When I collect the data, what is the total amount of sample I should have? Let's say 100 samples in a day, right? And so sample should be adequate and sample should be independent. And then who should collect the data? And you are assigning that also, Mr. X. And when that individual should collect the data, should he collect the data only from a particular shift or from all shift? And then within a shift, at what time you should go and collect the data. So that information also you should tell. And how will data be collected? We want the data to be, do you want the data to be collected in a random manner or in a systematic manner? Random means, anytime he can go in a particular shift and then collect the data. Systematic means every 4th output or every 10th output, every 100th output, he will collect the data. So something like that, right? So how the data should be collected. And then X number of data that can be collected at the same time. This is nothing but subgroup size. When the data collector goes to the field, he is going to take sample. At a time, how many sample he should collect? At a time, how many sample, right? Let's say in a day, I want 100 data. But the first shift itself, I will collect, 10 sample. First shift itself, I will collect 10 sample. And within within first shift, I go 2 times to collect 10 sample. So the first time, I'll take 5 sample. And the next time, I will take 5 sample. So how many samples I am taking at a time? Only 5 samples. The 5 is called subgroup size because every shift I am taking data in 2 subgroups. And so every subgroup I am going to have, let's say 5 sample, which is called subgroup size. That means in a shift, I am getting 10 samples. 10 samples in 2 subgroups and each subgroup size is 5. So in a day, the company is running for, let's say 3 shift, and every shift I'm getting how many data? 10. So 3 shift, I'll get 30. So in order to get 100 data, probably I will collect the data for 3 to 4 days. So this is how you must plan the data collection. And now you can see a beautiful format developed here, and which is called the check sheet, right? And additional columns based on the requirement you can introduce. Please note, when you are collecting the sample is actually a subgroup taken from the population. We are really interested in understanding the characteristics of the population. For that purpose, we take sample from the population and then we study the sample and collect the sample properly without giving any room for error, both measurement error as well as sampling error, because sample should truly represent the characteristics of your population. Otherwise, what will happen? All your inference you are going to draw from the sample will direct you in the wrong direction. Hope all the lessons we have discussed in this video you are able to understand, and I'll meet you with some more interesting tools in the next video. Thank you.